All right. Hi, everyone. I'm going to get started here with the talk. So my name is Andy Guibert. I am a developer for IBM. I currently work on the Open Liberty project. And today I'm going to talk to you guys about a game that I developed kind of for this conference here. It's called Liberty Bikes. It's a multiplayer online game for 1 to 4 players. And we built it using microservices and the latest APIs that are out there. So first of all, I have to give a shout out to my team. These are their beautiful faces back in Rochester in the United States. So we all kind of carved off a different part of this project, and we're able to have pretty free domain over the back end, and I'll get more to that later. But we had 4 members on this project, and unsurprisingly, it's comprised of 4 microservices. And that's kind of one of the nice aspects of a microservice architecture right away, is that you can you can break apart your application and it can reflect the internal structure of your organization. I think some famous software evangelist said that one time, that inevitably your software will reflect your internal organization structure. And nowadays that Agile is a thing, and we like to, as developers especially, we like to iterate fast, push new code deployments. It's very helpful to have autonomously working teams that can develop new code and push updates without having to do an entire organization-wide coordination. So hopping right in, this is what Liberty Bikes looks like. So we've got a web interface and also a mobile interface that you can use to act as kind of the game controller. The objective of the game is to be the last player alive. So bikes kind of move around the map at the same speed. You leave a trail as you move, and you can just steer up, down, left, right. If you hit anything at all, you die. And like I said before, the last player alive wins. And to get in a game, you can either enter by joining a code. The rounds are pretty short, so we can get a lot of people trying out the game, and it's not a huge time investment like some other games that I've played in my day. And also we track the stats for the players across multiple rounds. So you'll see on the right-hand side of the screenshot there, we have player scores, and we have different types of metrics that we flip through as the game is going. So what I'm going to do right away here is cut away from the slides and just give a quick live preview of what the game looks like. So here's our login page. We have some single sign-on options, so you can authenticate with your Google, GitHub, or Twitter account and have your the spot on the leaderboard locked down so no one else can impersonate you. But for now, I will just sign in as a guest. Say my name is Andy. And I'll just quick join a game, and I'm going to start it immediately here. So I'm the green player in the top left corner, and I'm just using the arrow keys on my keyboard to move around. And these other 3 players are just basically AI components that we wrote that read the state of the game board and can make decisions accordingly. So I'm just going to die now and get back to the talk, because video games are fun, but that's not why you're all here. So that's the basic concept, and just to give you guys an idea of what the thing looks like on the surface. So for the rest of this talk here, I'm just going to be going into kind of looking under the hood and seeing what makes this game work and where did we find places to use the latest APIs. So this is kind of what the overall system looks like. We have, like I said before, 4 microservices, and note that the front end is an Angular app, but we just run it as a static web app, and all 4 of these microservices are running on Open Liberty deployments. And as we wrote this game, we found that it really modeled a traditional real-world application that you might find. So if we kind of look closer at what are the characteristics of this system, we have a non-Java front end, which is quite popular nowadays, and mainly just the fact that multiple languages exist, and things exist besides Java. So, and within the different services, we have freedom to choose whichever language or framework we want to, whatever is the best fit. We have a really CPU and I/O intensive service. That's our game service. So when you're connected to the game, that's where your direction changes and all that data is constantly streaming back and forth. Also, we have lots of internal REST communication that goes on inside the network. We persist our data to a database, and also this isn't just a completely closed system, right? So we do depend on the outside world a little bit. So for the authentication service, when you sign on through Google, Twitter, whatever, we call out to those publicly available REST APIs to authenticate you, and then you come back into the system. And kind of feeding into that, we allow single sign-on, which is kind of nice peace of mind as you're developing something. Like, I didn't want to be responsible for storing people's passwords in the database or anything, and knowing what proper encryption or hashing I'm supposed to be using. So being able to just punt that to a single sign-on provider was quite nice. So to kind of summarize the benefits of what this microservice architecture gives us and what microservice architectures in general give us, is that we can independently scale them. That's kind of the most obvious one here. So as I highlighted before, the game service is really CPU and I/O intensive. So I would love for this game to just blow up on Twitter. Maybe you guys can help me with that. But say we have 10,000 people wanting to play this game, right? We're going to need more than just one instance of the game service running in our cloud deployment. So we can scale out and make a bunch of instances of the game service, but the static front end and the authentication service, those really don't get hit very hard. And I don't want to have to pay to scale out the entire system when all I care about is scaling out the one piece of my, the whole system that is very, CPU and I/O intensive. And like I mentioned before, with the team structure, we could develop these independently. They were very easy to unit test and make sure the individual pieces work together. Feeding into that, we had a continuous delivery and deployment pipeline set up so that whenever we push updates to any of these services, we can restart them. For simplicity here, we just redeployed them all at the same time in a single pipeline. But if this was if I actually cared about my 9s of uptime, I would have these all in individual pipelines and be able to redeploy them individually. And also, we can have language and framework freedom. So I touched on this on the first slide a little bit. We used Angular on the front end and Java pretty much everywhere in the back end. We used a mix of MicroProfile and JWT EE APIs, but in this talk here, I'm going to be focusing mostly on MicroProfile, since that's kind of the new kid on the block. And then the last benefit that I wanted to highlight here for the microservice architecture is just the fault and security isolation that you get from having things separated out. So if one of these services blows up, whether that's it getting compromised from a security perspective or it just crashes, the whole system doesn't go down. For example, like if my player service crashes, I can still log in and play games. I mean, my scores aren't persisted anywhere, but I can, the game is still usable. And a classic example that gets used here is Netflix, right? Because they have a recommendation service, and if their recommendation service goes down, you can still watch Netflix, but you just don't have the customized recommendations, for you as a user. So it's not all a nice, easy picture. Many of you have probably heard the expression, there's no free lunch when it comes to microservices. So it does introduce a set of challenges with this sort of architecture shift. So I've identified a few of them here. And really, MicroProfile does a great job of sort of having an individual piece of the overarching MicroProfile platform that addresses these individual difficulties that are introduced with the microservice architecture. So the first one is lots of service-to-service calls. There are some libraries out there, such as like CXF and I think REST-easy, have third-party libraries for using a type-safe REST client. And I'll go into more detail on that later. But MicroProfile standardizes that in a way that is not locking you into a particular vendor. Also, we have more points of failure, especially with all the increased network traffic going on. More things are going to fail, and we need to be able to react to that. So MicroProfile fault tolerance introduces a set of annotations, basically that allow you to address sort of common failure patterns, and I'll go into that in more detail as well. And then being able to reconfigure your the whole system for your various deployments, right? So we have our dev and our production and our staging environments nowadays. And how many of you are familiar with the 12-factor applications, 12factor.net? Okay, so about half the room. That's good. It's definitely best practice to have your development and production environments as similar as possible. And that's good, but it can never be perfect. I mean, you can't run, if you have a huge system with dozens of microservices, it may not be practical to have all of your developers set up and run all of the microservices, especially if you're calling out to more expensive services to host, like databases and whatnot. So MicroProfile Config sort of gives an easy way to establish defaults for your configuration, but then override them when you move to production in a type-safe way. And lastly, handling authentication is another big one. I just got out of a really good talk downstairs that was kind of deep diving on this topic. But MicroProfile JWT helps to address the fact that since there's all these new pieces in a microservice application, they all need to be able to trust and authenticate the operations going through the system. And if they all had to check one centralized, authentication service on every single operation, that would be very bad, and it just simply wouldn't scale. So MicroProfile JWT helps to address that and reduce the stress you have on your authentication service, essentially, and safely and reliably pass state or pass authorization state through your system. So those are the technologies we used. As far as the tech stack we used, at the very base of this, I used Gradle. I am really a fan of it, being able to script out. We have the deployment for Liberty Bikes. It's 4 Open Liberty servers running that all talk to each other and whatnot. And with Gradle, we were able to get the setup for this project, which is hosted out on GitHub, down to a single command. So you can do git clone and then just run a one-shot Gradle command, and it will download all your dependencies and get everything up and running and wired together. Very similar to like a Maven clean install, but with a little more customization available. On top of that, my go-to Java environment is OpenJDK on OpenJ9. If you're not familiar, OpenJ9 is the, I guess, second largest open source contribution that IBM made, next to Open Liberty, of course. But it's a really good JVM. It is new, but it's derived from the IBM JDK, which has kind of long been, it's a very battle-tested JVM. So it's rock solid, and it has very impressive performance. And I think, Mike, did you already give a talk on that, or are you going to give a talk on it later? Tomorrow, yeah. So tomorrow, Mike is also from the WebSphere team with me, and he will be deep diving OpenJ9 performance with one of the OpenJ9 developers himself. And then at the core of the stack here, we have Open Liberty, which is a sort of a Java EE application server. That's what I work on in my day job. And for the past year or two, we've been working really hard to get to the latest points on both MicroProfile and Java EE, or now Jakarta EE. So Open Liberty, in the same app server, we support both Java EE8 or Jakarta EE8 and MicroProfile 2.0. So the latest of both worlds, and you can combine them both in the same application. So you don't have to pick between MicroProfile or Jakarta EE. So just a little more details on OpenLiberty itself. It's available on public GitHub. Contributors are definitely welcome. We're under the Eclipse public license version 1.0, and we have support upgrade options. So it's completely free to download and try it out. And then, excuse me, if you go into production, there's support options there as well. So one of my favorite things about OpenLiberty is that you can kind of right size your server. So it does offer the full MicroProfile and the full Jakarta EE stack. But if your service is only using a tiny fraction of that, right here I have a picture shown of my server XML, which is configuring primarily the features that my server is using. So to highlight a few here, I have CDI 2.0, JAX-RS 2.1, JSON B, and then MicroProfile Config, JWT, REST client, and fault tolerance. And this is probably just maybe 10 to 15% of the features available in OpenLiberty. And 10 to 15% of the server footprint as well. So once I have my server XML defined, I can actually compress down my server to not only just the memory footprint that is required by these features, but also the disk footprint as well. So that kind of helps to save cost, especially when you're deploying in a cloud environment, and your memory and your disk allocation, actually you're paying for it as you use it. All right, so on to some of the tech highlights that I wanted to cover here. So the first one is REST client. And this is useful if you have one service that needs to make a Java service that needs to call some other REST API. So in this example here, I've shown the part where our authentication service calls out to the GitHub OAuth API to get a token back. And this code example here is without MicroProfile REST client. So this is using a proprietary or a third-party CXF library to do this. And this code essentially formulates the GET request that I have above the code example. So with MicroProfile REST client, we can condense this down and turn it into a little bit more familiar interface. So this does the exact same operations as the previous code example I showed, except it's using standard JAX-RS annotations to define where the service is at, what path it's at, and also the parameters that go into it. And to use this, I can inject this interface as a CDI bean anywhere else in my application. And MicroProfile REST client will basically, just fabricate an implementation that backs this up. And to break down the specific pieces of the HTTP URL here, I have them highlighted. So the base of where the external service is actually located can be set in system properties, and MicroProfile Config can help with this. And I think in one of the later versions of MicroProfile REST client, they're actually looking at letting you set the base URL through annotations, so system properties aren't even required. And then moving on, we have the path at the class level and the method level. Another thing I like to highlight here is that the GitHub OAuth API is huge. When I first went to their doc page, they had dozens and dozens of operations, and all I had to do here was model the specific piece of the GitHub OAuth API that I needed, and I can just code that up in my interface how I need it. And also, I'm using a regular Java object to get the response back. So I've just put that right in the class, and JAX-RS will use JSON B behind the scenes to convert the JSON response that we get back into a plain old Java object. So the next feature that I want to highlight is our usage of MicroProfile fault tolerance. So here's the specific location in the system where we have an example of the game service calling over to another microservice, which may or may not be up, right? So for a simple fault tolerance scenario, I've just added the @retry annotation in my Java code, and this, if any exception is thrown on this method, the fault tolerance feature will automatically retry it 3 times immediately. And this retry annotation is also tunable. So if you want to say, you know, maybe retry 5 times, but wait a minute after each retry, you can, that's also configurable. Or if I only want to retry on, you know, IO exception and allow everything else to blow up and, you know, don't retry it unless it's an IO exception, I can also configure that right in the annotation. Similarly, the MicroProfile also offers timeout annotations, which is a way to cap how long the method is allowed to take. Circuit breaker, which is a way to sort of shut off the calls. So if you have, has anyone heard of the stampeding herd problem? Where you have, you know, if something goes down and if it comes back up, everything else, you know, tries to get the requests in all at once and then it just crashes again. So that sort of helps to alleviate this situation. And fallback is kind of a natural extension of circuit breaker, where you can define a fallback method to call instead in the event of a failure. So for example, if I want the game service to record, you know, tell the player service to record a score, but the player service is down, maybe an acceptable fallback mechanism would be to just have the game service attempt to cache the update in memory and you know, store that in place in a fallback, and then once it's back available, once the player service is back up, then it can just send through all of its messages. But that needs to be evaluated on a case-by-case basis, of course, but the fallback annotation makes it nice and easy. And another, so moving on to MicroProfile Config, this one was actually super convenient, especially for the services that need to call each other, right? So we have, you can make required or optional config parameters, and these are just injected as CDI values. So in the top there, I've established an optional value, which shows the auth service URL, and by default we just assume everything is running on the same machine, so I just put it on localhost. But if I'm running in a cloud environment, say, and all of my microservices are on different machines, then I can override this value to be whatever the host name and URL of that service is. Additionally, you can have required config properties, which are very nice because you can never forget to configure your application, or at least if you do, it will blow up and tell you right away when you start it up. And you don't, you know, realize it at 4 a.m. on Saturday after you've put it to production that you forgot to set a property. So MicroProfile is a very simple spec, but also very powerful, and it helps to sort of get the, you know, startup time validation that you would hope to get with configuration. So before, I also touched on security a little bit. How many of you have heard of JSON Web Tokens before? It's called, also known as JWT. Okay, so about half the room again. So to give a really brief overview of what JWTs are, it's becoming a very popular security standard. It's way more than just MicroProfile, and it's even way more than Java. So lots of languages are using JWTs. But essentially how it works is you get this base64 encoded string that's broken out into 3 parts that I have highlighted in red, purple, and blue there. And the top is basically a header that says what encryption mechanism is used, and the middle part is sort of the guts of it, which says I claim that this, web token has these claims, such as the username is Andy and he is an admin and also a user. And the signature at the bottom is signed with the private key of the service, and it basically says, you know, the client that wants to validate the JWT can use the public key of whoever issued it to verify that the information in the first 2 sections is actually correct and it can actually be trusted. So the reason why MicroProfile comes in here is because JWTs are very widely used, and they're almost like too widely used. So they're all over the place in terms of what claims are allowed. So here I just have a screenshot of JWT.io, which is a great resource if you want to learn more about JWTs. But this shows some of the libraries, and it has highlighted in red the certain libraries that don't support certain aspects of JWT claims. So what MicroProfile did here is we did two things, basically. We standardized it so we have a well-known set of claims that Java-based services will use, and also we integrate them with the existing security APIs. So highlighted on the left there, I have the roles allowed annotation, and I say basic there because I mean it's the basic usage, not because it's basic authorization. Sorry if that's confusing. And the custom section where you can also, if you need to do deeper inspection of the JWT besides just the roles that it's claiming to be, you can also parse out the individual pieces of the JWT. And what MicroProfile JWT will do for you is it will automatically validate that the JWT is a valid JWT that can be trusted at the time it's injected into the service. And if it's not, you'll get a 401, which means unauthorized. And the last example I'm going to touch on here is MicroProfile OpenAPI. And this was a technology that actually wasn't released when I initially wrote most of Liberty Bikes. So we just used a regular, JAX-RS annotations, which you can see on the left. And all I did to enable OpenAPI usage is turning on the feature in my server XML, and I didn't do anything else. And I got this nice UI, an interactive web user interface that allowed me to invoke the individual REST operations on my backend without having to do any other config or making any code changes to my JAX-RS resource. So if I expand out the UI, these are kind of the operations that I get. So you can have input parameters. It tells you the equivalent curl command that's being issued in case you want to script this out, and it also shows the response code as well as the response body. And also to clarify here, similar to JWT, OpenAPI itself is also a standard that goes beyond MicroProfile and beyond Java, and MicroProfile OpenAPI is just bringing that standardization into the Java space, so it's easier to consume. So now I'm going to cut away from the slides again and do a short code demo. So now that I've explained all the various building blocks of the application, I'm going to go through and look at the OpenAPI user interface here and invoke some operations. So this is the user interface for the player service, which stores like player registration and scoring. So if I hit try this out, I'll create a new player. I'll call him Andy2. And if I execute that, it tells me it was successful, and the ID for my user is basic Andy2. So if I go down a little bit more and I get the information for my player and execute that, I will see that I am indeed created in the database. My name is Andy2. I've played 0 games with 0 wins, and I have an initial rating of 1,000 points. So pretty basic. But in addition to creating and reading user data, this service also stores ranking information. So there's this nice ranking endpoint here, which if I was a malicious user that somehow got access to the backend, I could invoke this command and say, I am Andy2, and I came in first place in this game. And if I click this button a lot of times, I am giving myself wins. And if I go back up here to the get operation, I haven't played any games, and now I have 12 games played, 12 wins, 100% win rate, and probably first on the leaderboard. So that's not very good. So now I'm going to use MicroProfile JWT to secure this endpoint down so that anyone can't go and boost their scores on the leaderboard. Sorry, Mike. So to do this, I have the ranking service code. This is just a regular JAX-RS resource, and I'm going to say the roles allowed here. Oh yeah, sorry. How's that? Better? Okay. So I'm going to say roles allowed. Oh wait, I lost my focus there. and I'll say I only allow admins to play this game. So I just added that annotation to the JaxRS resource and hit save in my IDE. And this is a really subtle point that I want to highlight here, is that Eclipse here automatically recompiled this class, and the class file showed up in my build output. And without restarting the server at all or running any Maven commands, this code is now live on the player service that I have running on my local system. So if I go back to the OpenAPI user interface, I'm just going to recreate Andy2, and I'll check the score here just to make sure I'm reset. So yep, I have a rating of 1,000, so I'm back to the initial state. And now I'll try to boost my score again, and when I hit execute there, I got response code 401 with error unauthorized. So that's good. So now we know that this backend REST endpoint is secured, and I can't access it unless I have a valid JWT in place with the admin role available. So that's good, but remember that the game service has a valid need to call the player service and update scores. So what I'm going to do next is hop over to the player service, and I will add an authorization, or I'll add a header parameter. And this is just a regular JaxRS annotation. So now the player service REST interface view that the game service has of the player service has been updated, so it requires, in my code at least, to pass through an authorization header. So now if I go over to the game round itself, where I send the code updates, you'll see that I have a compile error here because I added that new property. So I will just add a bearer token, and I will call this convenient create JWT method that I already have coded out. So typically in a real world application, your JWT will come from some external service. So that's why I'm not going to highlight here exactly how I create it. But if you go to JWT.io, there are several Java libraries that you can use to create a JWT, and then fill it with whatever claims you want. And the key use case that MicroProfile is addressing here is it's making it easy to consume that JWT. Once it's already been produced, it can just easily be passed around throughout the various backend services in the application. So now I've hit save in my IDE, and this is in the game service, so now that has been updated. And if I hop back to a regular game, I'll play as Andy3 now and sign in as a guest. And I'll play a new game. And if this works properly, after the game is over, my score for Andy3 on the right-hand side of the screen should be updated when I requeue to the next game. So the bots will die eventually because they're not the smartest. And when I hit requeue here, Andy3 now has a rating of 1,014 points. So I think I got second place there, so my rating went up a little bit. But point shown, the game service is now able to properly call the player service and update stats, but an outside actor cannot come in and call that rating service without having proper authorization. So any questions on that so far? I've just got a few more slides to wrap up, but if anyone has questions, just feel free to raise your hand and interrupt. Yeah, go ahead. Yeah, so you don't have to use MicroProfile REST client to pass the token around. Any way that you can you can get the authorization header into the HTTP request is perfectly valid. So since we're short on time here, I'm going to cut past the JaxRS 2.1 highlight that I have in the slides. And if you're interested in learning about this more, we have 3 different instances of Liberty Bikes deployed on IBM Cloud. So the URL is up here. You can play this any time of day. Also, we have a GitHub repository out on public GitHub that has nice setup instructions that tells you how to clone and just get the whole thing running locally with the one Gradle command. So that's all I have for today. I will be at the IBM booth the rest of the week. We'll be running Liberty Bikes there. If you have further questions, please come talk to me at the booth. And don't forget to rate the session. Thanks, everyone.